Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Mission Space is a hardware and software company that's an emerging player in space weather intelligence. They're developing real-time monitoring and forecasting solutions that safeguard both Earth-based and space-based infrastructure. Its flagship technologies include a space weather operations system, which is a forecasting platform delivering 96-hour alerts with 500-kilometer resolution, powered by proprietary machine learning models, and the Zohar Satellite Constellation, a growing network of low Earth orbit sensors providing high-resolution, space-originated environmental data. The company serves multiple sectors, including defense, satellite communications, aviation, power grids, GNSS infrastructure, and space tourism. Headquartered in Miami with a European presence in Luxembourg, they aim to be the NOAA of the commercial space era. And joining me on the Journal of Space Commerce podcast now is Mission Space CEO Mary Glazkova. And Mary, thank you very much for joining me today.
Thank you very much for having me, Tom. Yeah, we are aimed to be hyper-NOAA.
Hyper-NOAA. We'll talk about that in a little bit, but let's begin by talking about what kind of sparked the founding of Mission Space and what problem were you really determined that you were going to solve?
Well, the founding of Mission Space was driven by a hard quantifiable problem. Current space weather monitor system, it doesn't meet the operational needs of today's global infrastructure, especially in the age of mega constellation, deep space missions, and AI-powered infrastructure. For instance, the number of satellites grew from 1,400 from 2016 up to 11,000, and the projection of 400,000 satellites within the next decade. Each of them depends on environmental modeling to avoid damage from surface charge, to radiation exposure and surface charging and other issues. And 90% of operational space weather satellites are aging, and mission also rely on complex and expensive ground infrastructure that also fails sometimes. And what's important, there's no specific mission dedicated to capture complex real-time multi-point measurements of the polar cusp and the South Atlantic anomaly. Those are both critical regions for space weather dynamics.
So then, how does space weather directly affect daily life on Earth that most people really don't pay attention to?
Well, yeah, despite of sounding remote, space weather has immediate and very measurable effects on systems we rely on every day. Let's start with aviation. Solar storms, magnetospheric and ionospheric disturbance caused by solar storms, they disrupt high-frequency radio communications. And airlines like Delta or United, they sometimes reroute or delay flights due to the risk of the space weather. And during the solar storm last year, or maybe like 2 years ago, Cat Pacific had to divert 3 flights. And this is all not speaking about the higher radiation exposure during the solar particles coming with the storm. Another example, it's power grids. Geomagnetic storms overload transformers, and it's damaged the hardware and it forces shutdowns. One example that everyone likes to talk about it was many years ago in like 1989. But it left 6 million people without electricity for 9 hours.
Right,
And
that was the one that took down the grid in pretty much the entire northeastern U.S., as I recall. Is that
right,
the
right.
event you're talking about?
Yeah,
Yeah.
Hydro-Quebec power grid. Exactly. Yeah,
So then,
and
go ahead.
yeah, and another example is GPS.
Hmm.
We rely on GPS heavily. Magnetic storms increase ionospheric disturbance, which reduce the precision of GPS-based services. And this affects like everything from harvesting, because we now use John Deere's equipment and autonomous tractors. They rely heavily on GPS, and of course the aircraft navigation. And for instance, the Gannon storm, also like an example that everyone talks about a lot, uh, caused almost 500 million in damages to US farmers,
Hmm.
because the tractors, they just cropped the wrong field. That's it. Yeah, and of course, satellites and communications. If you remember, Starlink lost 40 satellites in 2022 due to
Hmm.
the unexpected drag shortly after the launch.
I guess as more and more companies move towards things like autonomous vehicles on roads and so many things that are being dependent on drones now, this whole thing about the GPS is going to become even more critical at a time when GPS is almost becoming obsolete. And that's going to be something that's very important, I'm sure, for your company.
Absolutely.
Talk about the differences, Mary, between your platform, the Space Weather Operations System, from traditional government-led space weather models.
Well, if I may say so, with all the respect, traditional models rely on physics simulations and simple statistics, and the accuracy fails, drops after like 6-12 hours. And they also output like broad indices, which don't reflect the local risks. Our system keeps high accuracy longer, up to 96 hours now, and we're working on improving that. And also, we deliver location-specific insights. We're about to introduce an localized impact maps for 100 kilometers resolution, will focus on critical zones such as polar caps and the South Atlantic anomaly. Also, government systems rely on aging assets, and we want to control the full stack from in-orbit measurements up to the user notifications.
I want to back up for just a moment and let's talk about what space weather actually is, because I'm sure there are some people that really don't have a concept. When they think about the weather, they think, is it going to rain today? And that's not what space weather is all about. So give us a kind of a primer on space weather, if you would.
Right. So there are, where do I start? So if you look at the sun, you might see the spots.
Mm-hmm.
So those spots, this is the signal that something is going on there. So once you see the spot, it means that they're either one second.
Oh, you're fine.
Yeah, I'm just trying to think how to explain that, like in a
in terms that I can understand.
well, for the broader audience, yeah, just
Yeah.
not to go to
But when people talk about space weather, they often talk about sunspots, they talk about solar
Right.
storms, they talk about the aurora borealis, which we never get to see here in Florida. But those are the kinds of things that I think that space weather is the most that's what is the most recognizable for people on Earth. But there's more to space weather than that.
Well, maybe it's easier to say that what a solar storm is.
Hmm.
Solar storm refers to like a broad category of disturbance originating from the sun. That includes solar flares. That's explosion of the sun surface emitting X-rays and radiation. The second one is coronal mass ejection. It's like a huge cloud of magnetized plasma ejected into the space. And the third one is solar energetic particles event, so-called SEP event. It's high energy particles accelerated by flares or coronal mass ejection shock fronts. So how does it affect the Earth? It affects like in a form of geomagnetic storm. Uh,
Hmm.
so it's a disturbance of the Earth magnetic field triggered by the solar storm. When solar storm wind or coronal mass ejection hits Earth magnetosphere, it compresses and distorts the magnetic field, and energy transferred into magnetosphere and ionosphere. And this triggers fluctuations in geomagnetic indices, if it makes sense.
Yeah, it does. And so then when that kind of energy hits a satellite or makes it through, and I know that the Earth's magnetic field is the protection that we have from all of that solar radiation that allows us to actually live on this planet. So when that hits like a satellite or something of that nature, what happens?
It interacts with the magnetic field. So this is how you can lose the asset. Or if we talk about radiation, and for instance, the crewed missions, the crew is exposed to the radiation that, of course, affects the health
Mhm.
directly.
Let's go and talk a little bit about the Zohar mission and what kind of data you're collecting in orbit.
So the current mission was designed to generate high resolution, low latency data streams. And I actually have the sensors here, so I can show them. This is a spectrometer. It measures the energy spectra of charged particles from mid to high energy. And alpha particles. It helps identify solar energetic particles, as I mentioned, SEP events in real time, and distinguish between background radiation and storm events, and classify the potential impact.
And for
And
those of you listening on the radio, it's a little silver box about the size of a pack of cigarettes.
uh, yes, it's very light and very small, and this is like we're proud of it. And this guy, it's a Cherenkov detector. It uses light generated by high energy particles traveling faster than light speed
Hmm.
in detector medium to measure flux levels and particle velocity profiles. These are crucial for quantifying high energy protons that can degrade satellites, electronics, or pose risk to aviation crews and the astronauts' health.
And that one looks, if you've ever taken apart your computer, that looks kind of like the hard drive.
All right. Yeah, so those are our proprietary sensors, and space weather sensors, they used to be like the size of at least like a huge microwave or
Hmm.
even bigger. And those guys, it's 1 kilo, and it feeds small satellites.
Well, Mary, then who are your current target customers and what problems are they looking to solve?
Well, as I mentioned, like satellites and space traffic management companies, they experience the satellite drag and orbital unpredictability during geomagnetic storms. They lead to expensive re-entries or also to the complete loss of assets and poor collision risk modeling. They need high resolution, low latency, real-time thermospheric density and radiation forecast to adjust the maintenance and collision avoidance in advance. And also, as I mentioned, aviation, because flights can't go over the polar region because they will lose the communication during the solar storm. They need alerts like many hours before the flight.
Sure.
Yeah, and again, power grids and government agencies, for instance, like NOAA and NASA, again, because their missions, they're past due and they need the data and real-time data so they can provide better products for those who rely on them. And of course, like lunar Mars missions, supersonic and hypersonic missions, these systems face unshield radiation, surface charging, plasma effects, and critical communication risks during the space weather events. They need forecasting tools, basically, that work outside Earth's magnetosphere, and so they can adapt to the environment.
My guest is Mary Glazkova, CEO of Mission Space on the Journal of Space Commerce podcast. Take a moment right now to click subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Xterra Media. And please consider becoming a paid subscriber. Whether you're a space professional, an investor, or an enthusiast, paid subscribers have first access to premium articles and podcasts focused on the new space economy. Just visit www.xterrajsc.com and help keep the Journal of Space Commerce independent as we chronicle, cajole, and, when necessary, critique the commercial space industry. Mary, let's talk about your partnership with Contact Space and how that will shape your global reach.
Contact, it's a Korean company based in South Korea and Seoul. And our partnership with Contact, it's a step in building global and scalable space weather intelligence network. Contact operates a rapidly expanding network of ground stations across Asia, Europe, and the Middle East. And for us, this partnership ensures first frequent downlink opportunities. In comparison, legacy missions often depend on once or twice daily passes. We are looking for 10 over 10 passes per day. And another thing is that with Contact, we can gather data on differences between the planned trajectory of a satellite with the factual one. Those differences can tell you if there's something going on there, if satellites were affected by the neutral density, and so they experience their atmospheric drag.
Now, you also recently announced a collaboration with Starcatcher, which is an interesting company. I've talked with them on the podcast before. What are you going to be doing with Starcatcher?
Well, Starcatcher is also based here Florida, and we're looking on creating a resilient and intelligent infrastructure for satellite power and space weather monitoring. We're going to supply Starcatcher with precise, low latency radiation and particle flux data from our constellation, and Starcatcher will provide beamed power to our satellites.
Solar cycle 25 is kind of ramping up, and for people who pay attention to such things, the sun does operate in cycles. Are space weather threats on the rise with that solar cycle actually starting to get geared up a little bit?
Well, the short answer is yes. Originally expected to be mild, and it's already exceeded the predictions. We see more sunspots, like 30%. The number is like 40% higher than expected, comparing to the same period in the previous cycle. So more sunspot means more solar flares and coronal mass ejections. Should I repeat that?
No, you're fine.
Okay, good. So as I mentioned before, those trigger the geomagnetic storms on Earth. And during the I think it was in May, the shortwave radio and GPS signals were disrupted during the X class flare, and again, I think in May, Starlink satellites adjusted the orbits due to increased atmospheric drag.
Just a couple of things more. What role will your forecast, when people think about space weather, if they think about it at all, they think about it having to do with Earth, because that's where we live, and that seems to be the most important thing to pretty much everybody who lives here. I get that. But what kind of role is your forecasting system going to play when we start stretching out to the moon or get into Martian missions?
This is my favorite part.
Okay, good.
I'm a big believer in lunar missions and Mars missions. And unlike Earth, the Moon and Mars, they don't have the strong magnetic field and thick atmosphere. So solar energetic particles from solar flares, they pose severe health risks to astronauts, and of course can damage the electronics. Radiation plasma fluxes accelerate surface charging, and especially on the moon's night side, and that leads to static discharge and can and will damage the rovers, landers, and habitats. So our charge density model tools forecast these effects in advance. So operators can go to safe modes or reconfigure the hardware. Also, you can put our sensors on a rover, so it can operate autonomously, and you don't need to have an operator to change the modes of the operations.
This just occurs to me, and it's kind of an off-the-wall question, but I'm going to ask it anyway. When you think about the development right now of solar sails, and I'm a sailor. I love being on a sailboat, and we know that it's the wind that powers the sailboat. Well, I think, am I correct in assuming that these kinds of solar events are the same thing that create the quote-unquote solar wind that is going to make space space travel possible using solar sails? And do you see yourself eventually as being a forecasting company to say, oh, the solar wind is good this day for this particular trajectory?
I love it. It sounds something like from a sci-fi novel right now, but
Right.
everything is possible, and I'm a pilot, so yeah, I do see how a space weather company helps you to fly from a planet to planet, like a weather app helps me and other pilots now to fly your plane.
I've got a PPL in my pocket too, so
Yeah.
I get it. One thing more, Mary, and we ask this of all of our guests, and that's to look down the road 10 or 15 years and think about space commerce and the role that mission space is going to play. And tell me what you see.
Um, if you follow the Axiom missions,
Hmm.
the current one, so they started to explore the radiation starting from the first mission, and during the first one, I think there was like a shielding, and then like a next generation shielding, and now they have wearable devices, and this is where I see us like in 5, 10 years. I want to see all astronauts wearing mission space devices that alert them on space weather events while they are building something on the moon.
Okay. Well, it's been a great conversation, Mary. I really appreciate your time today and best of luck. And we'll check in with you down the road and see how things are going.
Thank you very much, Tom.
Mary Glazkova is CEO of Mission Space. And that's going to do it for this edition of the Journal of Space Commerce podcast, a production of Xterra Media. The executive producers are Mike Turner and Tom Patton, with production assistance from Debbie Turner. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, Audible, and many other popular podcasting platforms. Be sure to click subscribe so you don't miss any of our podcasts or any of our other videos. You can get daily updates on space commerce by subscribing to the Journal of Space Commerce on Substack at www.xterrajsc.com. You can connect with us on LinkedIn and follow us on X at XterraJSC. And please consider becoming a paid subscriber. Whether you're a space professional, investor, or enthusiast, paid subscribers have first access to premium articles and podcasts focused on the new space economy. Just visit xterrajsc.com and help keep the Journal of Space Commerce independent as we chronicle, cajole, and, when necessary, critique the commercial space industry. I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers, like Galileo. The proof is looking glass. That's for reason. Our dreamer's eyes we gaze into a sense of purpose, know my view. Like finding one